Hello everyone, this video covers the lecture notes for week number 2. The notes will mostly be about fractional expressions, and the whole topic is gonna rely on factoring. Factoring is one of the most important techniques or one of the most important tools for you to remember in order to do well in calculus. So therefore all of these 5 objectives we have here, 1, 2, 3, 4, 5, they all rely on factoring at some point. Okay. Now before we do any examples, so let me make a side note. So when it comes to factoring, since it's very important for you to remember this, this is probably the best way to approach factoring. So whenever it comes to factoring, the first thing you should always check is for the GCF, or the greatest common factor. And after that, you're gonna go by the number of terms that you have in the expression. So if you have two terms, we're gonna use a formula. So there is technically 3 formulas that you will be using over and over. If you have 3 terms, you're going to do trial and error, which technically means guess. And if you have 4 terms, we're going to do something that is called grouping. And grouping works 99% of the time. You have 4 terms. You can always change any that is 3 into 4, and we'll do that. So if the guess is pretty complicated, you can always change it into 4, and it will make your life easier. All right, so let's try the first example. Notice here that the GCF is x minus 3. You have x minus 3 and x minus 3 there. So therefore the GCF, or greatest common factor, is x minus 3. So when it comes to factoring, you write the GCF first, which is x minus 3, then parentheses. Now there are 2 ways to look at this. What is a number that when you multiply times this will give you this? So obviously is this one, 2x plus 4. Now if it wasn't obvious, you could have done this. This takes longer, but you can see for yourself that this actually makes sense. If you were to multiply this by x minus 3, which is the GCF, you can see that this will cancel, so the only thing left will be the 2x plus 4. And that's how we got this value right here. This is this. If we do the same thing for the next value, so clearly this one has to be -5. And that's it. So that will be the GCF. Okay. Now, if there is more than to do than the GCF, then you have to go to this, or this. For the next few problems, we'll just be focusing on this part. Okay, let's try the next exercise. Again, remember that this may not match exactly the number or the page number, but the problems are the same, the ones you have in the book, in case you want to look to the book. All right, so here, the first thing you need to do is figure out what's the GCF. So you need to see what they have in common. You can see you have x minus 2 here. We have x minus 2. You have x squared plus 4, x squared plus 4. And then this one has a x, this one doesn't have a x, but this one has a 2, this one has a 4. So therefore they have the 2 in common. So when you find the GCF, you have to pick everything that is different. So different, you have the 2, which is this one right here, this 2. And then times x minus 2, which is this one, and it's x minus 2. And then the other thing that is different is x squared plus 4. So those are the three terms that are different. Then you need to pick the smallest exponent. That's very, very important. So if you look to the x minus 2, the smallest exponent between 3 and 4 is 3. So we're going to go with 3. The smallest exponent of 4 and 5 is equals to 4. So that's how you're going to find the LCD. Then we need to find the value that goes here, so that when you multiply it times this one, it will give you this whole expression. Now, remember, you can just guess, or you can do it the long way. The long way was this: 5 x squared plus 4 to the 4th power times 2x times x minus 2 to the 4th power, and we divide everything by the GCF. And the GCF is 2x minus 2q times x squared plus 4. Okay, so remember that this one is the GCF. And if you have the right GCF, you should never have any fractions in here. Things should cancel nicely, and this is what I mean. You can see that the x squared plus 4 will cancel this one. The 2 will cancel this 2. This one is q, this is a 4, so this will cancel. You only have one left. So therefore, the things that do not cancel or that they survive is the phi, the x, and this part. So therefore, the value that you need to go there has to be phi x times x minus 2. So therefore, the value that will go here will be phi x times x minus 2. Now, why is this 1? Well, you remember from elementary algebra, you have y to the 4 divided by yq. This will give you y to the 1. So that's how you get this part right here. Now, you should stop the video and verify this, that this makes sense, because this is the trickiest part for this problem. So if we do the exact same thing with this one, you can see that you should check that you will get now x squared plus 4 to the 1st power times 2. And that's it for that part. Now, this can be simplified more if you distribute. This will give you 5x squared minus 10x plus 2x squared plus a. So therefore, you can rewrite this as follows: q x squared plus 4 to the 4, and then the whole thing times 7x squared minus 10x plus a, and that's it. Again, the key to do these problems, if they look too messy at the beginning, is to do each part on the side or do it the long way. I know it takes a little longer, but it's safer. So you can see here, once you do this part on the side, you end up with this, and you just put it in here. And that's it, instead of guessing what's the value that goes there. Now, once you do this multiple times, you don't have to do the right side. You can just do the whole process in your head. But if you're not sure at the beginning, I highly recommend you to do this on the side to get these values here and here. Now, before we try these two examples, let me refresh your memory on the method of grouping. And in case you forgot it or you never learned it, this is your chance to redeem your sins. So here it is. So recall to do a grouping. Grouping requires that you have 4 4 terms. So you only have 3, you can add 1, kinda, to get to 4. And grouping works this way. Let me do the most basic example. Let's say you have ax plus ay plus bx plus by. So you can see that this is four terms. So then you will group this into 2. So we'll do this 2 and then this 2. That's why the name grouping. And it's like you had 2 separate problems. So what's the GCF of the red part? It will be A. So therefore this will be x plus y. And what's the GCF of the blue part? It will be B, and this will be x plus y. Now whenever you do grouping, you have to get these two to be exactly the same. This one and this one has to match, identical. Now that they kind of look the same, they had to be exactly the same. So once you get to that point, you are 90% percent done. Then whatever is outside will go in the other parentheses. So this is how grouping will work. Once you check that these two are exactly the same, you row them once. So you write that down once. And whatever is left goes in the other parentheses. And that's it. So this is one of the most useful ways to factor. So this one you only write it once, and whatever was left goes in the other parentheses. And that's what grouping is. Now, if you had 3 terms, grouping is not needed. However, you had to be guessing over and over until you guess the value in the middle. And if this number is not 1, this can take a long time. So instead, we're going to change from 3 to 4. And once you have 4 terms, then you can use grouping. So here is the trick. So you're going to multiply this value times this one. So it's multiplying. So 6 times 5 is equals to 30. And then what are all the factors of 30? 15 times 2. Also, obviously, 6 times 5. And also 10 times 3. Now, one of these 3, when you add it or subtract it, it has to give you 7. So that's the key. All right, so clearly 15 plus 2 is 17. 15 minus 2 is 13. So this will not work. 6 times 5, 6 plus 5 is 11. And 6 minus 5 is 1. So this one doesn't work either. But this one will. Because 10 plus 3 is 13. Yes, but 10 minus 3 is 7. Okay, so 10 minus 3 will give you 7. So this is the winner. So therefore, we're going to rewrite this. And you have already 6x squared. Instead of writing 7, we're going to write 10x minus 3x. So that will give you 7. And then the minus 5 that you already have. Okay, so again, the 7 is going to be written like this. This is still the same thing. The difference is that now you have four terms. So now we're going to do grouping. We're going to group these 2 with these 2. All right, so for the first one, the GCF is 2x, and then this is 3x plus 5. So this gives you this. Okay. Now, since in order for grouping to work, you need to get exactly this value, which you can see is almost there. All you have to do here is you factor the minus 1. And you can see now that this value and this one are exactly the same. So therefore, you write that only once, and whatever is left goes in the other parentheses, and that's it. So the only guessing you had to do it here is a lot easier than trying to guess all the values that go into parentheses only. Now you want to do it that way, that's perfectly fine, but you need to show the steps whether you use this method or the other one. Either way is fine as long as you get this. All right, well, you didn't get that one. This is the chance to redeem your sins. So here it is. So here we have 3 terms again. And since this is not a 1, it's gonna make the guessing pretty messy. So we wanna change it into 4. And we do the same trick again. We're gonna multiply 6 times 3, which will give you 18. Now what are the factors of 18? Obviously 6 times 3, 9 times 2, and 18 times 1. And you can see of these 3 choices, the only one that adds to 7 is this one. So this will work, this will not work, this will not work. The good news is that only of them is going to work. So therefore we will write this as 3x squared minus 9x plus 2x. Just make sure you have the correct signs, minus 6. And now you have 4 terms. Right, so again, we will write minus 7 as minus 9x plus 2x. And now you have 4 terms, so we're going to factor this and this separately. So the GCF for the first one is 3x. That will be x minus 3. Now, since we already got x minus 3, your goal is to get again x minus 3. So therefore, the GCF for the second part is going to be 2. And then this will be x minus 3. And you can see that this and this are the same now. So once you get to that point, remember, just write the part in green twice. So x minus 3 goes here, and whatever is left goes in the other side. So the x minus 3 goes here once, and whatever was left, which in this case was this, goes into the parentheses. Now, notice that you only had to do this usually if this is not 1. If this is 1, in the first value, then the guessing is a lot easier, so you don't have to go through this. But if this is not 1, guessing is going to be pretty messy. And this is what I mean. Let's say that you have something very simple like this. X squared minus x minus 12 equals to just minus 12. So this one, in theory, you're doing the same thing, but this one is easier to guess. You can see 4 and 3 gives you 12, and minus 4 plus 3 is minus 1. So there is no need to go through this process, but that's because this was a 1 and it was easier to guess. So if you have something like this, you can just do it this way. It will also work if you use this, but it's unnecessary to go through this if the problem is this easy. All right, so now the next example, this one connects this section with the first week, which in the first week we talk about the domain. And remember, you have a rational expression or a fraction. The only issue is that this can not be 0. Okay, so that's what part of last week was about. All right, so in this question is asking you to combine what we're doing right now, what we did last time. Here it is asking you for which values of x is this true. Well, this function has the issue that you can divide by 0 when x is equals to 4. So therefore, when is this true? Well, this is true for all x values except for x equals to 4. Or in interval notation, you can say from minus infinity to 4, union 4 to infinity. So this will be an interval notation. And in set notation, it will be x such that x is not equals to 4. So this is set notation. Okay, so we did this in the last video. Or we talked about the domain in the last video. And the next example is asking you to multiply and then simplify. This problem is pretty simple because it's mostly already factored. If it is not factored, you have to factor it first and then cancel things out. Now, before we simplify this, let's look to the box on the right side and says, for what values of x is the given expression undefined? Remember, undefined is referring to the domain, and the domain of this expression is all the real numbers except when x is equals to 1. So x cannot be 1, and for this part, x cannot be -1. -4. So therefore, for what values of x is the given expression undefined? Well, it's undefined when x is equals to 1 and when x is equals to -4, because they are not part of the domain. So 1 and -4, so these are not part of the domain, and that's what will make the expression undefined. Now, if you notice here, this is factor. This is factor. Is only one expression. The only one that is not factor is this one. But this is the same thing as x plus 4 times x plus 4. So once everything is factor, all you have to do is cross out like terms, one from the top and one from the bottom. Okay, so this will cancel this one. This will cancel that. And the thing that survived, that was not cancelled, is the 3 here, x plus 3, the x plus 4. So therefore the solution will be 3, x plus 3, divided by x plus 4. And that's it. Now, if this expression was not already factored, it will take a little more work because you had to factor it first. But the idea is the same. For example, let's say that we have x squared minus x minus 12 divided by, let's say, x squared minus 8x plus 16. Okay. And on the top, you have x squared minus 4x. And on the bottom, you have x squared plus 6x plus 9. So if this was the case, the first thing you will have to do is factor each of them. So this will be x minus 4 times x minus 4. It will be x plus 3 times x plus 3. We just did this one in one of the previous examples. So this is x minus 4 times x plus 3. And this one is x times x minus 4. And then you just cross out like terms. Remember, the only condition is one on the top, one on the bottom. So this will cancel that, this will cancel that, this will cancel this. So the only thing left will be x over x plus 3. And that's it. Alright, so this is another example. Remember, this is connected to this part right here. Now, this one is asking you to add or subtract the fractions instead of multiplying. And if you remember from elementary school, adding fractions is actually more difficult than multiplying fractions. But before we go there to solve the problem, it's asking you the same question. For which values of x is this undefined? Remember, undefined means it's not part of the domain, and the issue for this one will be 1 and minus 1. So therefore, x cannot be 1 and x cannot be minus 1. At this point, the expression will be undefined. Now, before I add this expression, let me refresh your memory on how to add fractions. Recall this. Let's say you want to add 1 over 12 or subtract the fractions minus 2 over 9. Okay. If this was the case, the proper way to do this is that first you need to factor this. And you can say this is 4 times 3, and this is 3 times 3. Okay. So the LCD should be everything that is different to the highest power. So in this particular case, the LCD should be 4 times 3 squared, which is 4 times 9 is 36. But this is how you should look at this, and it will make these problems way easier to do. So once you have that, then you can say, well, I have 1 over 4 times 3 minus 9 over 3 times 3. And remember that this is the LCD. So now the question should be, what is this missing from the LCD? And the only thing missing is the number 3. So multiply by 3. What about this one? Well, this missing 4. I know this looks pretty weird, but this is how these problems are going to be pretty easy to do. You use this method. All right, so then from here you will have 3 over 4 times 3 squared minus 36 over 4 times 3 squared. And then just simplify. So this will be minus 33 over 4 times 9, which is 36. And that's the answer. So that's literally what we're going to do here. So first we're going to factor. This will be x minus 1 times x plus 1, because that's a difference of squares. And this will be x plus 1 times x plus 1, or x plus 1 squared. So therefore the LCD is going to be everything that is different. So x minus 1 is different, and then x plus 1 squared. So you have this to this power, like here. See, 4 is different, why it was there. 3 is different, but the highest power of 3 was 2. So it's essentially the same thing. Then we're going to do the exact same trick. So for the first part, we have x minus 1 times x plus 1. So the question should be, what is this missing from this part? And clearly, the only part that is missing is the x plus 1. Okay. Then we move to the next one. And the x plus 1 times x plus 1. What is this missing from the LCD? Remember, this is this part, so the part that is missing is the x minus 1. So we multiply this by x minus 1. So therefore what we have is the following. We have x plus 1 over the LCD, because we know the LCD means this. You can leave it like this for now, just change it at the very end to this. And then minus 2 times x minus 1 over the LCD. And if we simplify this, this will be x plus 1 minus 2x plus 2 divided by the LCD, which will give you minus x plus 3 over the LCD. Okay. Again, notice that, okay, the x plus 1 obviously is the x plus 1. And you have to be careful when you distribute the sign. So this gives you this part. Now, this is technically the solution. This is perfectly fine. If it was a written test, you will get 100% of the points. However, remember that the LCD, you have an expression for what it is right here. So therefore, this will be minus x plus 3 over the LCD, which is x minus 1 times x plus 1 squared. And then this will be the answer. But this is perfectly okay. All right, well, if you didn't get that one, here's a chance to read it yourselves. It's another example. Remember, first thing, make sure that the bottom or the denominators are factors, so this will be x minus 3 times x plus 2. So therefore the LCD, it will be x minus 3 times x plus 2. And that's what you want to match. So for the first part, we'll have x over x minus 3 times x plus 2. Then we have 1 over x plus 2. And what's the part that is missing? The x minus 3. So multiply by that. And then minus 2 over x minus 3. And what's the part that is missing is the x plus 2. Also here, just be careful with this minus sign and this minus sign when it distributes. Now the first one is not missing anything, so you can just say we're multiplying by 1. Okay. So therefore from here we have the following. We have x over the LCD minus x plus 3 over the LCD. The minus and minus becomes plus. And then, well, you can write like this, plus, minus down. And then plus minus 2x minus 4 over the LCD. Or to make it easier to see, you have LCD, and this will be x minus x plus 3 minus 2x minus 4, which will give you just minus 2x minus 1 over the LCD. But remember, the LCD was equals to this, so you can just rewrite it that at the end and you're done. Even though this is technically okay up to this point, then the answer you can say is minus 2x minus 1 over x minus 3 times x plus 2. And that's it. In the next example, we had to simplify a compound fraction. A compound fraction is just a fraction divided by another fraction. Sometimes they're also called complex fractions. So here, to make your life easier for now, we're just gonna focus on in this part because we did this already in the previous examples. Okay, so just pretend that you don't see this part. So only focus on the yellow part. Okay? So if that's the case, this is what we have on the left side. We have the 1 over a plus h minus 1 over a. Okay. Here we need to find the LCD, and the LCD is gonna be a times a plus h or a plus h times a, since this is different than this one, so this is the LCD. All right, just like the two examples we did before, so this one is missing the a plus h, and this one is just missing the a. Okay? So therefore, if we simplify this will be a over the LCD minus a plus h over the LCD. So if we distribute the negative number, we have LCD here, this will be a minus h. So you can see that this will cancel. So you end up with minus h over the LCD, which is minus h over a times a plus h. Now, before we continue with the problem, notice this, and this is going to be very useful for you, not just in this class, but in calculus later. It's just a fraction trick, but it's very useful. Notice that you have, let's say, 5 over 9. This is identical to saying 1 9 times just 5, right? So that should be obvious, but so that you can just see it. So therefore, if we use this observation from here, we'll have that this is the same thing as 1 over h, times 1 over a plus h minus 1 over a. And trust me, this is gonna save you a lot of pain and suffering. We already simplify this, which was all this work, and give us this part. So therefore this and this is the same thing. So that's what we just simplify. So therefore this will become 1 over h times minus h over a times a plus h. And notice here that the h will cancel, and it will be just minus 1 over a times a plus h. And that's it. So that will be the answer. Okay, let's go to the last example. And this is very similar to the last 3 or 4 examples we did. There's a big difference that it has an equal sign here. But for now, let's pretend that the equal sign was not there. So you can see the connection. So let's say this is plus, which is not, but let's pretend it's plus. So you can see the connection with this to the last 3 problems we did, except for this one, but to the previous ones. Okay? Remember, if this was the case, the first thing you do is we're gonna factor this. So this will be x minus 2, x plus 1. We find the LCD. The LCD is x minus 2 times x plus 1. And we do exactly the same tricks we did for the previous method, or the same technique. What is this missing from the LCD? Well, this is missing x minus 2. Okay? Same thing. The next one is missing x plus 1. And the last one is not missing anything. So the last one you have x plus 3 over x minus 2 times x plus 1. And you can just put like you're multiplying by 1. Okay? So notice this is identical to what we did in the last few examples. Obviously, to finish this, if this was one of the previous examples with this plus instead of equal sign, then you simplify this, combine it, and you say divide by the LCD. The difference is going to be this. Since this is actually equal sign, so once you get to this point, you can just change this to the equal sign. This is also obviously the equal sign. And once you check that this, and these are exactly the same, you literally forget about the LCD, because the LCD is on the bottom, and you only worry about the top. So on the top you only have 1 times x minus 2 plus 1 times x plus 1 equals to x plus 3, and then you just have to solve this. And so then you just solve this equation. Okay? And you still have the LCD here, but since the LCD is the same for both sides, then you can forget about the LCD. So you only focus on the top. And then from here you will have 2x minus 1, you simplify, equals to x plus 3. And then you solve for x, this will be x equals to 4. And that will be the answer. Now, even though this question is not asking, the domain for this one is x cannot be negative 1, and x cannot be 2. That's the domain. If this one was 2 or negative 1, this problem will not have a solution. So therefore, this is fine. And that's it. So notice how you can do the equations and the expressions very similarly. For both of them, you need the LCD. Without the LCD, you cannot solve this problem. The difference is when you have a equation, you don't have to worry about the LCD after this point. You only focus on the numerators and just solve the numerators, and that's it. All right, so just in case you didn't get that one completely, let's do one last example. So let's say you're trying to solve this problem. Remember, the first thing you need to do always is to find the LCD, so you can factor this as x minus 4 times x plus 4. So therefore, from here, the LCD is going to be x minus 4 times x plus 4. Okay? Then we do the same trick for the first one. The x minus 4 times x plus 4 is not missing anything, so just multiply by 1. The second one is missing the x plus 4. And the third one is missing the x minus 4. And just be careful with the signs when you distribute, so it should be negative 4. All right, so remember, once you check that this, and this is the same, which is the LCD, you can forget about the denominator and just focus on the numerator. So from here, this means that x is equals to 2x plus 8. You distribute this minus 2, this is actually 7, so it should be a 7, times 7x, and then plus 20a, which will give you x equals to minus 5x plus 36, or 6x equals to 36, or x equals to 6. And that's it. All right, people, that's it for week number 2. See you in week number 3.